This concept clip is about random assignment and why it is important for the success of an experiment. Most introductory psychology textbooks explain this method very briefly and tend to emphasize how it is done, with little emphasis on why it is done and why it is essential to the validity of one's experiment. If you recall, in an experiment, we typically divide our subjects into at least two groups, one being the control group and the other being the experimental group. If they behave significantly differently, and all of the extraneous or confounding variables have been controlled, we can assume that the manipulation we provided is the cause of any differences we found. The difficult element here is to effectively control all those variables, particularly the ones the subjects themselves bring to the experiment. What we want is for the extraneous variables to have the same influence on each group. Suppose we tried to prove that a couple of cups of coffee improve cognitive processing and manual dexterity. We might then create a control group that receives no coffee, or a placebo pill, and an experimental group that receives 2 cups of coffee, or coffee in a tablet form. We then have both groups play a video game that no one has played before. If we control for the extraneous variables and find a significant difference between the average scores for the groups, we can conclude that the difference is explained by the manipulation we provided, because that is the only difference between the groups. We control the variables with the process of random assignment of individuals to groups. We draw the subjects' names out of a hat, or by computer these days, and let the computer decide randomly where to put the subjects, either in the control group or the experimental group. Now comes the possible problems. The differences between these individuals can be very substantial and very significant in their ability to affect the outcome of the experiment. Some might tolerate coffee better than others due to inexperience or weight. Some may have never played any video games at all, while others are experienced gamers. Some might have gotten up on the wrong side of the bed or had little sleep the night before. A few might be sick, and some might be more motivated for one reason or another. This list barely scratches the surface of the potential differences or potential confounding variables for this experiment. Randomization is intended to distribute these differences equally between the groups and thus cancel out or balance the potential unwanted effects. Many students doubt the ability of this method to adequately balance the effects of the extraneous variables. Some suggest that we might manually balance the most significant factors, say the skill at video games or the weight of the individuals, or the fact that they do or don't normally drink coffee regularly. We could start by taking the 2 heaviest individuals and put one in the control group and the other in the experimental group. We might continue that process until all of the individuals are distributed evenly into the groups by weight. The problem immediately becomes evident because each of those individuals have different levels of experience in playing video games and many other differences. We could somehow try to redistribute them according to video game experience while trying to not disturb the balance in the weight factor, but even that would not easily be done. Multiply this process by all the factors we can identify, and you can see that this would not work very well. There are also many extraneous variables that we might not have even thought of. So the random assignment technique remains the best method of distributing all the variables equally into the groups. It does so automatically across the board, including all of the variables we're unaware of. Many of you at this point are probably still skeptical about how effectively this can be done. Think of it this way. Suppose you have only 3 people in each group. The differences we distribute into each group are not going to be very effectively balanced into the 3 groups. Just by random chance, you could easily have most or all of the experienced video players in one group, or most or all of the caffeine-tolerant individuals in one group. This obviously will not work. But suppose you instead have 1 million subjects in each group. If the computer has randomly assigned all 2 million subjects into one or the other of the two groups, each group should have very close to an equal number of individuals with each quality, that is, experienced video players, caffeine drinkers, etc. Well, you might say, what experiment has 2 million subjects? None, of course, but consider this fact. It has been established from thousands of experiments that certain minimum numbers of players, roughly 30 per group as a good rule of thumb, allows a sufficient number of subjects to provide a significant result, given the magnitude of the differences found. So if you find a very large difference in the average scores of the two video game playing groups, fewer members are required in those groups to consider those results to be significant. If your differences are very small, the number of subjects required for significant results will be very large. This should be evident from the example with the extreme numbers I offered earlier. It is therefore to the researcher's benefit to have as many subjects as is practicable. I think you might now be able to understand why the process of random assignment of individuals to groups can be effective, but also critical to the success of the experiment.